Welcome to aminacademy.com. In physics, regarding thermodynamic process, let us discuss about adiabatic process. In thermodynamics, an adiabatic process is a type of thermodynamic process that occurs without transferring heat or mass between the thermodynamic system and its environment. Unlike an isothermal process, an adiabatic process transfers energy to the surroundings only as work. As a key concept in thermodynamics, the adiabatic process supports the theory that explained the first law of thermodynamics. In an adiabatic process, the system is insulated from the surroundings and heat absorbed or released is zero. We see that work done by the gas resulting in decrease in its internal energy and hence its temperature for an ideal gas. We quote without proof that we will prove the adiabatic process work done in adiabatic process now. Here, look at this figure. This is a adiabatic curve. Gamma equal to Cp by Cv. That is the ratio of specific heat at constant pressure divided by specific heat at constant volume. Here, this is a PV diagram. Here, this work done is the shaded area. We have to prove this formula. Look at here. First, for adiabatic curve, we know that PV power gamma equal constant and gamma equal to Cp by Cv. Now for two conditions P1 V1 and P2 V2, we have P1 V1 power gamma equal P2 V2 power gamma. Here we'll calculate work done between V1 and V2, that is work done equal integral to V1 to V2 of PdV, which is equal P is from that P is 1 by V power gamma, which is equal, instead of PV we can write that so constant into integral V1 to V2. Instead of P we can write it's 1 by V power gamma dV, which is equal W equal constant into, here integrating 1 power V1 over V power gamma is, first we write here V power minus gamma V1 to V2 dV, which is equal constant V power minus gamma is V power minus gamma plus 1 over minus gamma plus 1. Then two limits V1 to V2. We are applying the limits for V2 and V1. We will get W constant by 1 minus gamma. This 1 minus gamma will come here, and which is 1 over V2, we are applying the limits V2 and V1. V2 gamma minus 1 over V1 gamma minus 1, which is further equal W equal 1 over 1 minus gamma here. We know the constant. The constant is P1 V1 or P2 V2. The constant, instead of constant we are writing here P2 V2 P2 power gamma, because it's adiabatic process. It is a constant is P1 V1 power gamma is equal to P2 V2 power gamma. That is over here we are writing V2 power gamma. Like that here. Similarly you can write P1 V1 power gamma over V1 power gamma minus 1. Now simplifying this, we'll get 1 over 1 over gamma 1 over gamma, and simplifying this V2 and gamma minus this gamma and gamma, that it go P2 V2 power gamma which will give P2 V2, because here V2 power gamma over V2 power gamma and power minus 1 is equal to V2 minus this side is P1 V1. We know that P1 V1 equal to MRT by Gauss law, therefore which is equal work done equal 1 over 1 minus gamma P2 V2 minus P1 V1 is equal mu RT W equal, we can say mu RT, because P2 V2 minus P1 equal V1 equal to mu R T2 minus T1 minus T2. Here T over that gamma is 1 minus gamma is changing as gamma minus 1, because instead of T2 minus T1 we are writing T1 minus T2, therefore 1 minus gamma is interchanging as gamma minus 1. So this is the work done. That is work done equal mu RT T1 minus T2 over gamma minus 1. This is the work done expression for adiabatic process. Now we'll do an example problem to understand this concept. We often have the experience of pumping air into bicycle tire using hand pump. Consider the air inside the pump as a thermodynamic system having volume V at a atmospheric pressure and room temperature 27 degrees Celsius. Assume that the nozzle of the tire is blocked and you push the pump to a volume 1/4 of V. Calculate the final temperature of air in the pump. For air, since the nozzle is blocked, air will not flow into tire and it can be treated as an adiabatic compression. Now, for adiabatic compression, we can write T initial into V initial for gamma minus 1 equal T final V final gamma minus 1. Here the temperature is given in degrees Celsius. We have to convert in Kelvin. Ti equal 27 degree plus 273. Kelvin is 300 Kelvin. Now we have to find T final is the question mark. What is the final temperature? Also V final is V initial by 4. This is given. Now that from this relation we can get it T final minus T initial is equal V initial by V final gamma minus 1 from this relation. Therefore, T initial is 300, Vi by V final is 4 by 1 because 1 by 4 is V1 by 4 is T final. Power gamma is 1.4 minus 1 which is equal 300 into 4 power 1.4 minus 1 is 0.44 which is equal 300 into, by calculating this value, 4 power 0.4 is 1.741. After calculating that T final equal 522 degree Kelvin which is equal T final equal 522 minus 273 which is equal to 49 degree Celsius. This is a very high temperature because temperature of boiling of water is 100 degree Celsius, but it's 243 degrees. It is very high temperature. So when blocked pump, we should not touch the pump. It is very hot. It damage your finger. We have done. Please subscribe our YouTube channel.